time and change runtime type. So I want you to make sure that you're connected to a GPU. By default, it's usually connected to a CPU. But for this session, I want you to use a GPU. Now Colab gives us access to a T4 GPU. It's free, but it has its limits. So once you click on the GPU, you can just press save. We are using a GPU so that we can train our model faster, because when you're building and training a model like this, it usually takes time. So using a GPU will speed up the process. Now we can start by importing our libraries. So this code here is that we're importing some packages we will need. I'm importing NumPy. I'm importing TensorFlow. Then from TensorFlow.keras, I'm importing datasets, layers, models. So these are tools that will help me in building an image classifier. Then I'm importing matplotlib for visualizations. You will see the visualizations later. But for now, let us run this cell by clicking execute. So what's happening is I'm connecting to a compute engine, which is a computer in the cloud that allows me to run my code. Right, so we're done with this part. So the next step is to load and preprocess the data. And this data set we're using, it's available in TensorFlow. That's why we imported data sets, because TensorFlow also has data sets that we can use. And I'm using a data set known as CIFAR-10 data set. Now, this CIFAR-10 data set has 10 classes, meaning 10 different objects that we want to classify. And if you come over here, you can see the objects. We have an airplane, pictures of airplanes, automobiles, birds, cars, deer, dog, frog, horse, sheep, truck. So those are the images that we have. We have 60,000 of these images. So there are 60,000 images available in this data set. And this is the size. So the size of the images are 32 by 32. So when I load the data set, I'm going to do something, which is divide it into the training set and the test set. The training set is what we're going to train our model on. Then to be sure that our model has actually learned something, I'm going to keep a separate part of the data. I'm just going to keep it so I can use it to evaluate my model. It's like in all those math textbooks where you have some examples in the book of how they solve a particular problem, and you're learning through those examples. After a while, you want to be sure that you really understand what you've learned. So you go to the end of the chapter and you see some test questions there. Now, the answers to those test questions aren't available, so you actually need to solve it. And when you get the right answer, you can maybe confirm from the back of the book. So that's how this works. We want to make sure our model really knows what it's doing. So we split the data set into the training set and the test set. Now, this other line of code is we are normalizing the images. Now, normalization is important. Let's see what it looks like, what a picture pixel looks like. This may not be clear. Let me use a full screen. So this is your image. Now, if you should go in, this is what your computer sees. Your computer sees numbers, basically numbers. These numbers represent the intensity of the color, things like that. So usually the highest pixel value we have is 255. And we can't use 255. We don't want to pass in that to the model. We want the numbers to be normalized. Normalized means we're going to divide it. We're dividing it by 255, meaning all the pixels. We want the pixels to have a value between 0 and 1. Why do we want it to be between 0 and 1? So that the training process will be faster. Remember, the old deep learning process, it's expensive computationally. So we want to reduce the image pixels, let it be between 0 and 1. So that's what normalization does. So I'm going to run this cell. Now it's downloading the data from the site, and it's done downloading the data, and now we have our train images and test images. The next thing we're going to do, we're just going to visualize some of the training images. We want to see what the pictures look like. So I'm going to run this cell. Okay, remember the image size is 32 by 32. So that's why it's really small. And it's okay this way. Reducing the image size to 32 by 32. It's also going to make the number of pixel values we're looking at smaller. And that's going to make our training faster, because the normal pictures you snap on your phone could be like 720 pixel or even up to 1000 or 2800, or yeah, 2000, 2 megapixel. That's like really large. And so we need something small. So this is 32 by 32, which is okay. So you have a picture of a frog, truck, a deer, horse, bird. I mean, as a human being, you can actually identify some of these pictures the way they are right now. Right, so the next part is we're going to build our model. And for image classification, to build your model, you need to use something known as convolutional neural network. And this is the part where we define the convolutional neural network. Can't really go deep into everything here. Well, let's just look at some things like the convolutional layer. So this part is one of those layers that is going to detect patterns in the image. For example, we have a horse. So the convolutional layer is going to go through the image and try to find some patterns, some shape, something that it can use to know this is a horse. For example, it could be that the horse has 4 legs. So it just gets 4 lines and like, okay, this stuff has 4 legs. It could be a horse. And for truck, you could just recognize the shape, this shape, like some kind of square shape. So that's what the convolutional layer does. The max pooling layer, what it does is it just reduces the size of the images. So let's just run this part. Okay, so we have a neural network defined. The next thing is to compile this model. So this part, imagine what you've done here is like you are building a gun. You have your gun ready, but there are no bullets in the gun, so you can't really use it. Now, this compiling of the model, this is where we put in the bullets and make the gun useful. So this is compiling the model. And what we do here is we specify the optimizer. That's the algorithm that will make it do the classification, and define the loss function and the metric. Metric and loss function, they just help us to know how well the model is learning. So I'm going to run this part. Now, this is the next step. The next step is the training process. So we are passing in the training images and the training labels. When we pass the image, we also pass the labels, so the model knows that this picture it's seeing, it's a car, and it has to learn what makes it a car. And we're setting the epochs to 10 epochs. And we're also passing in the validation data so we can evaluate how the model is doing while it's training. So I'm going to run this cell. So we see the training process. Now, since I'm using a GPU, this part is going to be fast. But if you're using a CPU, you're going to realize it's going to take time. So model is learning right now from the images. we can see the accuracy in the first epoch is 44%, and the accuracy, training accuracy has improved to 59%. So it's getting better as it's going through the images over and over again. It's learning and it's getting better. Same thing with the validation accuracy. It's increasing, which means the model is actually learning because the validation data is data it hasn't seen before, and it's actually doing well. Let's see how accurate our model will be after the 10 epoch. Okay, so it's done training, and we have a training accuracy of 78%, and we have a validation accuracy of 70%. This means that if we give the model maybe 10 new images to look at, it's going to get 7 of those images right, and the other 3 it's going to probably misclassify them. So now that we're done training, what we're going to do is to evaluate this model. So let's check how well our model is doing. We're testing it on the test set. So again, just like what we have had here, that's the value we are just printing out. You can see the test accuracy is 70%, and the test loss is 0.89. So another thing we can do is to visualize this as a graph. You can visualize the whole training process as a graph to see how well our model was performing while it was training. I'm going to run this out. Now, this graph shows us that as the epoch was increasing, the model's performance was also improving. So the accuracy started from 45%, and it was improving over time until it got to 70 something percent. Same thing with the validation accuracy. And the loss, which is the error, typically what we want to do is want the loss to reduce. That's the error margin, we want it to reduce. And we can see as we're training the model, the loss is also reducing. Okay, so now that we've trained our model, let's see if we can use this model to make predictions on new data. So that's step 8. We're using the model we've trained to make predictions on some images in the test set. So running the cell. Okay, so this is the result. Now this result, it's showing this way because we have 10 classes, 10 different classes. So the one with the highest number represents what it's predicting. But to be sure, let's just visualize everything. Let's visualize the images and the predictions so we can see what the model is predicting. Okay. Well, our model is, I think, 70% accurate. So with the training time, it's not doing bad. So this is a cat, and the model predicted it to be a cat. So the model got this right. And this is actually a sheep, but the model predicted it to be an automobile. So this one is wrong. The ones in red, the model failed. Well, for the ones in blue, we can see the model is actually doing well. Predicted truck as a drop. Oh wow, predicted this to be a deer. I wonder why. Oh wow, a sheep is a so this is a really simple example of image classification with TensorFlow. There are other examples you can check out. You can learn other techniques. There are other complicated concepts like trying to make your model better. One thing you can do is you can increase the number of epochs. Hopefully that can also improve your model performance, but not in all cases. Sometimes it may not necessarily improve your model's performance. Right, so that's it for this presentation. I hope you've been able to learn something about building image classifiers with TensorFlow. Going back to the slide. Right, so again, thank you for joining us in this session. And you can subscribe to my YouTube channel to keep up with me. I have TinTechDom where I talk about where I teach Python and I produce data science related concepts. And Ini-Abasi Affiah is a personal YouTube channel. You can also follow me on LinkedIn and Twitter. I'm active there. And if you have questions, you can reach out to me via LinkedIn or via Twitter. So I've shared the link to this slide with you. It's in the chat, you can access it. So now, if you have any question, I think there's still time. Any questions now about TensorFlow, about deep learning, machine learning, anything you have in mind? Yeah, go ahead.
When classifying images, does the extension of the image matter? Or if it's an image, it's okay?
The extension of the image, do you mean like the size, the resolution of the image?
No, like the .jpg or something like that.
Oh, okay. Well, I won't say it matters that much because normally we usually use JPEG or PNG images. But what happens is there's a process before training your model where the images are converted to tensors. So it doesn't matter the format your image is in. You just during the image processing, that's before the training happens, you do a lot of pre-processing. So there's a stage where you convert the image to tensors, which is what the model will understand. Hope that answers your question.
Yes.
All right. Any other question? Okay. Victor, are you still here? Stefan, it seems you had wanted to ask something. Okay, if there isn't any other question, I guess that's it for this session. So see you guys in day 3 tomorrow. Yeah, I think it's by 4 p.m. So thank you again for joining and see you guys.
Thank you.
You're welcome. Hello.